Hello, 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 everybody. We're going to be starting another Euclid here, the 2006 Euclid, and this is actually the last time I'm going to get to wear one of these medals, because the 2006 Euclid was the last one that I actually wrote. I had a quick glance through it before I started recording. I actually don't remember most of those questions. 10 I vaguely remember, but no, I don't remember most of the questions. It has been a long time since I've written any of these contests. But yeah, here's my Euclid Medal that I won for the 2006 contest. I was school champion. Doesn't mean that you don't need to do super well. You just need to beat everyone else at your school to get one of these, and it's certainly attainable for some of you out there. And yeah, so I'm just gonna wear it for the first video, and you probably won't see much of it. The same with when I wore my Fermat medal and my Pascal medal and stuff. But just a celebration and to show you. Yeah, it's fun little medals. What is it? It's a heptagon. It's got a nice little Euclid there inside, and it's got French on the back because it's Canada, English and French. But I obviously prefer the English side as I barely speak French anymore. Okay, so let's jump right into it. The 2006 Euclid. So as we usually do, we peruse the front page. CEMC are the fine folks who make these contests up. They have a whole committee dedicated to making up the Euclid contest. Every year they make some great questions, and this year was no exception. So we got the fantastic sponsors here, MapleSoft, Waterloo, London Life, and Great West Life, all these fine people. And I like that they donate to help these contests and help make math enrichment in general. A standard Euclid contest, 2.5 hours. Calculators are allowed. You'll find calculators won't help you a whole lot. Because most of these questions are designed so that it's sort of like, I mean, the calculators are all well and good, but with the proof style questions, you can't calculate your way to an answer that'll get you full marks. As I say, so there's the short answer, there's full solution questions. Full solution, you've got to write everything out. You've got to prove. And some people say, I can't do proofs, I can't do math. It's just explaining what you're doing at every step, justifying what you're doing, rather than saying, answer's 5. So you have to explain, where did that 5 come from? How do you know it's going? So we know these two lines are parallel because this and this and these angles, and that gives us a length of this, which gives us a length of 5 for the radius of the whatever. So you just need to explain it every step. And that's all a math proof is, but some people get scared off by the word proof. So there's the full solutions. There's also the light bulb questions indicate short answers where you can get full marks just by writing down the answer of, say, x equals 5. Okay. So as you get further in the contest, you get more of the full solution, the proof-style questions, less of the light bulbs. And yeah, again, as you go through, the questions become harder, with question 10 being something that only a few people will get in its entirety and get full marks on. If this is your first time writing a Euclid, obviously it wasn't my first time because I managed to win. You shouldn't expect to be school champion the first time you win. But if this is your first time, don't focus on doing question 10. And if this is your first time writing any math contest, one of the most important things to realize is that you're probably not going to pass. You're not supposed to be passing the Euclid, even if you're a 90s student in your grade 12 calculus class. These are tricky questions. These are questions that require a lot of thought, a lot of justification, especially for the later ones. They are not your average question. Don't feel bad if you get 20 out of 100 on the Euclid, especially if it's your first time. That's okay. 30, 40. These are failures in the sense that you didn't get over half of all the available marks. But it's not a math exam. It's not a math test. It's a contest. Right? As long as you're sitting there writing and you have a little bit of fun, you're a little intrigued, you're challenged, that's the point. Okay? Don't get overwhelmed by questions 8, 9, and 10. They certainly take me a while when I do these videos, and they are not meant to be done by the average student. Okay? They're there to separate, as we say, the men from the boys, and they're there to tell us who is really, really good and who is really, 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 really good. But if you're a competent student, shoot for 30, 40 if it's your first time, and even that might not even be completely attainable. Okay. As I say, 100 marks on offer, but we're just going to go through this one question at a time in each video. So we're looking at question 1 in this video. Then I'll take this medal off and we'll go with question 2 after that. So question 1's got 2 light bulb questions and then a written question. This is a fairly common occurrence on the Euclid, 2 light bulbs and a written for question 1, also usually for question 2. And then they start doing this light bulb written, light bulb written, light bulb written, light bulb written, and then eventually around question 8, it all becomes written. Okay, but that's thinking way too far ahead. 1A. What is the sum of the X-intercept and the Y-intercept of the line 3x minus 3y equals 24? Okay. So X-intercept, Y-intercept, let's rearrange this so that we can get those forms. That's certainly one way to do it. Rearrange to get y equals mx plus b. And then there's the lesser known X-intercept form, y equals m times in brackets x minus a. That would be a perfectly acceptable way to do this question. Another way that you could do it is, what are the X-intercept and Y-intercept? Well, the X-intercept is what you get when y is equal to 0. And the Y-intercept is what you get when x is equal to 0. Couldn't we just plug those in and solve for the other? And that'd be another way to do it just as well. Okay? So you can pick either method. There's probably some more methods. If you got a different method than those two, feel free to leave a comment below. But we'll open up our notepad. And so 0b is the y-intercept. So 3x plus 3y equals 24. So that means 3 times 0 plus 3 times b is 24, or 3b is 24. B is going to be 8. Divide both sides by 3. A0 is usually what we use to denote the x-intercept. So that means 3a plus 3 times 0 is 24. A is going to be 8 as well, and we want the sum of these two. A plus b, 8 plus 8, 16. There we go. And that 16 would be worth the full marks, whether or not this was worth 2 marks, 3 marks. As long as I got that 16, I'm done. But if I didn't have 16, maybe I goofed and I'd made an arithmetic error and I put 17. Having my work there shows that, yeah, I knew what was going on. I just fumbled a little bit, and so maybe I'll get 2 out of 3 marks. But if I just put 17 with nothing else backing it up, I would get nothing. It's all or nothing on a light bulb unless you choose to justify it with some work. So if you have time, you find yourself, you've done question 4 and you just look at 5, 6, 7, 8, 9, 10 and you say, I can't do those, go back and justify the light bulbs. Write down a little bit of showing your work. Justify the light bulbs that you just put a final answer for. Or you can justify as you go, however you want to do it. So 1b, if the lines px equals 12 and 2x plus qy equals 10 intersect at 1, 1, what's the value of p plus q? Okay. So let's copy down these lines. Px equals 12 and 2x plus qy equals 10. They both intersect at 1, 1. So if I sub in x equals 1 and y equals 1, I should get the same. These equalities should be true. So p times 1 is 12. Or really, p is 12. That's great. 2 times 1 plus q times 1 is 10. So 2 plus q is 10. Not that hard to see from there that q is going to be 8. P plus q is then 12 plus 8. 20, and 20 is all we need to get the marks, but we have shown our work. You might even say sub in this common point here. Now, whatever C is, we do need to write a full solution there, so I'm going to flip the page in anticipation of C, just taking us a little bit longer. Okay, C. In the diagram, the line x plus 2y equals 12 intersects lines y equals negative x and y equals x at points A and B, respectively. So they've got that shown here. What is the length of AB? Okay. So the length of AB. Well, let's copy this picture over, and then we can scuff it up with any of our pesky numbers and calculations and so forth. So we've got. I'll put our lines in blue. So there's y equals x. There's y equals negative x. Now, one thing to notice, I don't know if it's going to particularly help, but these two lines, they have slopes which are negative reciprocals. Negative 1 over the slope of one is the slope of the other, and that means that they're going to intersect at right angles. This may or may not help us, I don't know. Then we have another line streaming across here. It was 2x plus y. Well, x plus 2y equals 12. But if we take this right angle into account, looky here, we have a right-angled triangle. Okay. So AOB would be a right-angled triangle. I don't know if this is going to help us, but there it is. I think probably the easiest thing to do is figure out the coordinates of A and B. And so I'm going to write down what I'm going to do. This signals to the marker, this is what I'm doing, so you can follow along more easily. If a marker can follow along, read what you're doing, and understand what you're doing, they're more likely to give you the marks that you need. If you're confusing, if you're just plucking numbers out of nowhere, that doesn't show that you really understand what's going on, and that maybe you happen to be copying from another paper that you can see and you don't really understand, and you're likely to lose some marks. So let's find the coordinates of A and B. So these are just intersection points. So B is the intersection of y equals x and x plus 2y. So we have y equals x, and we have x plus 2y equals 12. So sub the first one and the second one. X plus 2x, because y is equal to x, is 12. So 3x is 12. X is 4, and since y is equal to x, y is 4. So B has coordinates 4, 4. All right. How about A? Well, A is the intersection of x plus 2y equals 12 and y equals negative x. So replace y with the negative x. We get x minus 2x equals 12. So that would be negative x is 12, x is negative 12, and so y would be negative x, it would be 12. So now I know the coordinates of A. It's negative 12, 12. And that fits with the picture they gave me. A over here is in the second quadrant. So negative x values, positive y values. Now how are we going to get the distance? Well, there's a formula for the distance. AB is the square root of, you take the difference in the the x coordinates and square that, and add on the difference in the y coordinates and square that. Okay? So this is a nice common formula. If you didn't know it, that's okay. It's the distance formula. And we can use it anytime we know the coordinates of the 2 points that form the ends of the line segment. Okay? It comes from a quick little right-angle triangle here. The difference in the y's and the difference in the x's squared, square rooted, gives us the hypotenuse. All right. We don't have to prove that, by the way. I'm just explaining the distance formula in case you didn't know it. So 4 minus negative 12, that's going to be 16. So 16 squared plus 4 minus 12 is negative 8 squared. So that's 256 plus 64. The 4 and the 6 add up to a 10, so that's 26 plus 6. So a square root of 320. We could leave it like that, or we can take out, there's a factor of 16 in here. So 16 times 12, there's a factor of 64 in there. So we can say square root of 64 times 5, or we can say 8 root 5. Both of those would be acceptable. Root 320 is probably acceptable as well, because that is the right answer. AB is 8 root 5. Okay. So that's fantastic. We could have used the right angles here, but we would have first had to calculate OB, which I'm just going to quickly do in my head would have been 4 root 2, and this one here would have been 12 root 2. Okay, and then squaring those and adding them up together. So squaring that would be 32 squared or sorry, 32, and then that would be 144 times 2, so that'd be 288. And so once we add those two together again, we get 320. So that's another way to do it, but that would have required two operations with the distance formula, not just the one we have here. But I like it when there's lots of ways to do a question. Okay, so that finishes up question number 1. We did A, B, and C, and in C we explained where we were going. We said we're going to find the coordinates. We proceeded to find the coordinates of A and B quite quickly, subbing in. And then we used distance formula. If you wanted to, you could have said, now let's use the distance formula. You could have written down the general distance formula, but you don't need to. It all flows quite nicely. They're not asking you to be super exact and explain everything with paragraphs and paragraphs of text. But if you think something's unmotivated, you explain it. That's generally the rule of thumb. And the more of these contests that you practice, the more you practice writing things up, the more you watch other people, like me, write these things up, you will know what things are critical, what things should be written down, what things constitute a proof. Now, when I do my videos, I don't do full sentences all the time and everything, but I get the gist of what's up there. And that's something that you need to know. You need to sort of find the appropriate balance for you writing up your proofs. See what gets you marked, see what doesn't. General rule of thumb, if you're explaining it to a friend, or you can imagine explaining it to me, that's what you do. How would you explain it to me if I hadn't heard of this question before? How would you explain it to your friend who's also studying these contests, who's also going to write the Euclid? Don't explain it to your teacher, because you always assume your teacher knows what they're doing. And don't explain it to yourself, because you'll tend to omit things that you think are obvious or trivial, or like, yeah, it's got to be 12. Why wouldn't it be 12? And that sort of thing. So try and explain it to a friend. That's sort of the best way to set up a proof. But that's question 1. We're going to jump into the next video for question number 2, so you can join me there. Thanks for watching.